In the last class, there was a discussion about the assembly language programming using MCS 51 microcontroller. So these are the list of the popular programs with assembly statements or mnemonics of 8051 microcontroller. So you can study and go through. I think it has been sent to you. If not, then again I will resend it. So sorting a arrays of number in ascending or descending order, finding the largest number from an array, smallest number from the array, generate the Fibonacci series factorial of a given 8-bit number, and converting the codes, that is BCD to hexadecimal or BCD to binary or binary to BCD, gray to binary or binary to gray code. So these are the important things. These are the sample program, popular program. So in the textbook, these programs are available anywhere. You can go through the workout of this assembly language program. So as well as how the timer can be programmed, there are two timers represented as T0 and T1. So the timer and counter programmings are also discussed. Different modes of function. What are the registers for timer control, that is T mode, T con? These are the salient point. In fact, we can go through the programs because time is very short to complete the syllabus. So step by step, these are analyzed, and the sample program for the timer and the counters are also given here. Only thing, you have to determine the parameters for T mode registers, T con registers, and the timer data registers, high byte, low byte, etc. So this is very simple. Generating the large time delay requires a nested timer programs. Two timers can be programmed by nesting procedure. So how the large time delay can be generated, these are also given the sample program. Today what we discuss about the interrupt programs. Interrupt programming for the 8051 hardware external interrupt. There are two types of the interrupt that I have discussed. Internal interrupt, that internal interrupt can be generated by the timer overflow, as well as the serial data communications resources. But externally, with the applications of the transitions of the logic signals from 0 to 1 or 1 to 0, there is a two multifunction pin. So these are the two pins. So this pin number 12, as well as this pin number 12 is dedicated for sensing the external hardware. The functional name of this pin is called the INT0, as well as the same pin can be used for port access purpose, that is port 3.2. There is another external hardware pin called INT1, the pin number 13. And this is a multifunction pin so that it can be used as a simple I/O port pin. Functional name is P3.3. Now, what is the basic concept of the interrupt? You must be familiar when you have studied the 8085 vector interrupt and the hardware interrupt. So basically, by a simple definition, the interrupt is an external or internal event that interrupts the microcontroller or CPU program or microcontroller to inform that it is a device needs its service. A single microcontroller can serve the several devices by two ways. By processing the interrupt signal, whenever any device needs its service, the device notifies the microcontroller by sending it an interrupt signal or interrupt request signal. Upon receiving the interrupt signal, the microcontroller interrupts with whatever it is doing, that means executing a program, and serve the devices. So what is the process? The program which is associated with the interrupt program is a special type of subroutine which is called the interrupt service routine, ISR. Alternative name is interrupt handler. So when this interrupt request signal is raised, the CPU will save the status of the current program it is executing where? To the stack memory. And automatically it will branch to a specific address which are assigned to the respective interrupt signal. Respective interrupt signal means these are the chart for the total interrupt of the MCS 51 microcontroller. Reset is basically an interrupt signal, that means power on reset or manual reset. So applying a reset signal to the reset pin, the CPU of the microcontroller will automatically jump to the specific location in the program memory 0 hex. And reset is applied to the pin number 9 of the microcontroller. Similarly, external hardware, that is pin number 12, is an external interrupt signal which is generated by the external device, the hardware devices. And this is called the INT0, interrupt 0. And its vector location, its address location for the ISR is 0013 hex in the program memory. Now, timer 0, interrupt, timer 0 is an interrupt. Timer 1 can generate the interrupt. So these are the internal interrupt, not hardware. That means whenever the timer 0 overflow occurs, automatically and if the interrupt system is enabled, obviously interrupt will be sensed by the microcontroller only when the global interrupt system is enabled by setting an appropriate interrupt register flag. So there is a separate interrupt flag, that is icon, or I will discuss what are the name of the functional name of the interrupt control registers. So timer 0 and the timer 1, which are designated by TF0 and the TF1 as an internal interrupt, source of the internal interrupt, and this will occur when a overflow of the timer, respective timer will occur, and the starting address of the ISR is 000B and 001B. In a similar manner, we will study the serial data communication by 8051, so that by sending the data packet, a byte of data, as well as the receiving the data packet, upon completion, interrupt will be invoked, or interrupt service routine will be invoked. The starting address of the serial data communication is 0023. That is the only single location for receiving the serial data byte as well as sending the serial data byte. That means when all the bits in the data packets in the serial data communication, either asynchronous, synchronous, will be completed, and interrupt request will be raised. So these are the concepts. We will study more about when the serial data communication how the serial data combination will occur. So this is the source of the interrupt in 8051. Now, how to program the interrupt? These are written upon reset, all interrupts are disabled. Means there is an interrupt control register and there is a flag setting, so the flag setting is clear and the interrupt system is disabled. Even though there is a source of interrupt will request for interrupt service, then also it will not be done or processed. Disabled means alternative name is masked, which means that none will be responded by the microcontroller if they are activated. Activated means when the interrupt request will occur. The interrupt must be enabled by software or the program in order for the microcontroller to respond to them. How? So there is a register, interrupt control registers, IE register. That means different interrupt systems or the source of interrupt must be enabled. That is responsible for enabling the unmasking and disabling that means masking the interrupt. Enabling means unmasking and disabling means masking the interrupt systems. So there is a relative bit pattern of the IE registers, which is called the interrupt enable register. The D7 bits is the most significant bits. That is EA, enable interrupt systems, enable all interrupt. So this must be set to 1. So that the independent interrupt source of the interrupts will be enabled. What are the independent source of the interrupt? For external interrupt, the D0 is EX0, D1, D2 is EX1. For timer, D1 bit of the I register called ET0, it is a functional name, and D3 bits are called ET1 for the 2 timer. ET2 is separate, that means for 8052 microcontroller there are 3 timers. So 3 timer will raise the, 3rd timer will raise the interrupt and the bit setting for bit is called the ET2. This is undefined. And these are the functional name. User can set or reset the respective bits for masking or unmasking or enabling or disabling the interrupt system. But it should be remembered the enabling, masking and the unmasking will be effective only when the EA bit will be set. Otherwise, if the EA bit is not set, that means putting a 0, there is no effect on the independent source of the interrupt system or controlling the independent source of the interrupt. So that means putting 1 and 0, that means putting 1 to the respective bit position means enable this bit, enable the interrupt source of the interrupt, putting 0 to the source of interrupt, putting 0 to the respective bit, the source of the interrupt will be disabled. So that is the meaning. These are written also. To enable an interrupt, we take the following steps, which I have just now stated. Now, this is a sample program, assembly statement, how the interrupt should be programmed or the interrupt of the 8051 should be programmed. By using the data transfer bit and this is the bit setting, we can set all the bits because the most significant bit is 1. So enable all the bits. But the special purpose of this program is to enable serial timer 0 and the EX1. That's why this is a bit pattern. If you check the bit pattern according to the format of the IE registers. And how another way to perform the same manipulation. Here, using a single assembly statement. In other way, we can use a multiple assembly statement like set bit command. Set bit. Instruction of the 8051 has a bit manipulation statement, which 8085 does not have. For example, set B I 0.7 mean D7 bits is set or EA is 1. Global interrupt system is enabled. Set bit interrupt 4 means I enable the serial interrupt process. Similarly, I.1, I.2 enable the timer 0 and the external interrupt 1. So we can use either single assembly statement or we can use the multiple assembly statement. What are the difference? That means execution time will be larger in the second case. We can reset the particular bit interrupt in the interrupt registers by using the statement, assembly statement CLR IE.1 clear. Or we can use the move statement with the immediate operand in the respective bit position at 0. So this is how the interrupt control register should be, interrupt control register, the relative bits of the interrupt control register will be set and reset. For example, using the interrupt solve the problem here in polling. What is means polling? That means in polling without using the interrupt, the timer flag, that is TF0 or the TF1, when it is raised, that means timer flag in the TCON registers is set. Then by using the polling method, that means by checking the relative bit position, whether the TF0 or the TF1 bit is 1, the service routine can be invoked, but not the service routine. The microcontroller takes the decision. But without wasting, but this is a method, the microcontroller will be totally engaged for polling the timer flag, overflow flag. So it cannot do anything during that polling time. But timer interrupt is a process, that means without engaging the microcontroller to attend the service routine, the interrupt service, it can do the other jobs. It can do the other program. When the timer overflow flag will be raised or set, automatically the ISR will be called by the microcontroller. So using the interrupt, solve this problem and avoid the tying down the controller. If the timer interrupt in the I register is enabled, whenever the timer rolls over, that means overflow occurs, the TF is raised and the microcontroller is interrupted in whatever it is doing and jumps to the interrupt vector table, that is the starting address to service the ISR, interrupt service routine. In this way, the microcontroller can do other things until it is notified that the timer has rolled over. So this is the functional diagram of timer 0 and the timer 1 overflow flag. How the microcontroller, under the actions of the interrupt processing, will jump to the starting address, that is 000B or 001B. So this is very clear concept. The timer interrupt program is illustrated with the help of the timer interrupt programs. So this is the ISR. Now in assembly statements, I have discussed, that means there are pseudo code or directive, which are not the assembly statement, but these are the directives for the assembly program. For example, ORG, originate the program at this address to the program memory. Then the ISR, the starting address is written ORG 000B. That means ISR for the timer 0 to generate the square. The program, then the programming body, that is the assembly statement, will be below the ORG statement 00B. So this is the main part of the program, a single assembly line, long jump main. So bypass the interrupt vector table. So main is a some symbolic level. Somewhere in the plain one program, it will go on looping or some action. But whenever the interrupt will be raised by the timer 0, automatically this subroutine, which is located to the ISR starting address 000B, will be invoked. And the last statement, the return statement for the subroutine is return I, which means the return from the interrupt service routine. But if there is no I, it means normal subroutine. So the mainline program is like that. The main program for the initialization is like that. This slide that the 0030 statement or location. So you can see there are 3 locations. When the power on reset will occur, program will automatically execute LJump. And the LJump means long jump, and it will jump branch to the here. Where? At the address 0030. Then these will be executed under the actions of the mainline program. So there is a edge jump back. So infinite looping will go on here within the main programs. But whenever the interrupt will occur, automatically this will be serviced automatically. No problem. Then after completion of the ISR service routine, it will come back to somewhere within this block in the main program. So that is an example of the timer interrupt program. The timer has been initialized by this way. That means the part of the initialization is timer has to set its mode in the IE registers, as well as the timer data register should be initialized, that is T80, timer high byte, timer 0 high byte, so that ultimately when the timer will overload, then this will be invoked. Now, if the timer is programmed in the auto reload mode, there is a feature of the timer auto reload mode. Please read the auto reload feature. Then repeatedly, again the timer will be reinitialized. And this will go on, that means timer count will be decremented until unless the timer will overflow or overroll, will roll over, so that multiple times the timer 0 ISR will be executed. And another feature, what is the features of the ISR? It will just logically toggle a particular line P2.1. So ultimately what will happen? There will be a pulse will be produced at this port pin, either single time or repeated times, so that we can get a wave, a square wave for this program by using the interrupt method. So actually what we are talking, that means create a square wave that has a high portions of 1085 microseconds and the low portion of 15, asymmetrical or rectangular square wave, in which case the high byte has a longer width than the low byte or low period. But it is a symmetrical square wave, that means the on time and the off times are equal. So how the rectangular square wave can be generated, this is the part of the program. You have to study. You have to go through the examples and study. The third program, that is a generate the square wave of 50 Hz frequency on pin P1.2 by interrupt method. That means here it is a simple method. No, it is the interrupt method. So there is ISR routine. So using the interrupt, you can do these things, you can do this task, but without interrupt. But this is an interrupt method for the timer programming. Interrupt can be sensed by the level triggered or edge triggered. So there are 2 activation levels for the external hardware interrupt, which will occur at the pin 3.2 and 3.3. That means whenever there is a positive edge or negative edge, then the inter-service routine will be invoked. Otherwise, if the level of the signal changes from 0 to 1 or 1 to 0, not the edge, then and then also the inter-service routine will be observed. So that can be understood which is called the activation of the INT at 0. This is edge trigger. This is edge trigger. And this is level trigger. So in case of a edge trigger, I0 will be set. Okay. In case of a level trigger, it will be directly, this will go to the 0003. So that is the functional diagram of the edge and the level trigger for activation of INT 0 and the INT 1. And these are described. In the level trigger mode, INT 0 and the INT 1 pins are normally high. If a narrow level signal is a low level signal is applied to them, it triggers the interrupt. Then the microcontroller stops whatever it is doing and jumps to the interrupt vector table to service the interrupt. The low level signal at the INT pin must be removed before the executions of the last instruction of the ISR, return I. Otherwise, another interrupt will be generated. That's why there is a difference. Try to understand there is a difference between the edge trigger and the level trigger. That means if the size of the ISR is so small, but the level of the change of the signal will stay before that. So ISR will be invoked second time or multiple times. But in case of a edge trigger, this will not occur because edge means either low transitions or high transition. For example, in case of a low transition, it will be invoked ISR. But ISR will not be activated. Only one time it will be activated. So that's why there is the advantage of the edge trigger. But in case of a level trigger, if the ISR or the statements or the instruction under the ISR has been completed, even though the level stays to the activation logic, again the ISR will be automatically called. So there will be erroneous operation. This must be kept in mind. That is written here. The low level signal at the INT pin must be removed before the executions of the last instruction of the ISR. That is return I. That is the last instruction. Otherwise, another interrupt will be generated. This is called the level trigger or the level activated interrupt and is the default mode upon the 8051. Normally, when the interrupt system is activated, it is a default mode of operation. But in case of a edge trigger, this will not happen. This is an important point. That means pin 3, P3.2 and the 3.3 are not used for the normal I/O unless normally these are the pins for used for the normal I/O. But because these two pins are the multifunctional pin, so unless the INT 0 and the INT 1 beats in the I registers when it is enabled, then these pins will not be used as a normal I/O mode. It will be used as a source of the external interrupt, hardware interrupt. So that should be remembered, and that is explained. To ensure the activation of the hardware interrupt at the INT N pin, INT N means INT 1 or INT 0, make sure that the durations of the low level signal is around 4 machine cycles, but no more. So this is the mandatory condition, how long the level signal will stay, or the edge signal will take the 4 machine cycles, like this. On reset, INT 0, that is TCON 0.0 register, and IT 1 and IT 0, that is TCON point timer control register bit 2, are both low, making external interrupt level trigger. But using the TCON register, it can be converted to the edge trigger property. So again, remember the external hardware interrupt, and that's why the timer counter register should be recalled demand, the TCON registers holds among the other bits. What are these bits? So timer 1 run, because each timer has a timer overflow and the timer run. Okay. So these are the name of the relative bit. Timer 1 run control bit, that means it must be 1 for timer operation. Otherwise, if it is 0, timer will not roll. But when this bit is set, that is overflow flag, then the interrupt will be initiated. So that is the timer overflow flag. That is TF1, this, and the TF0. When this bit is set, then the timer overflow interrupt will be initiated. And in the IE register also, IE1 and the IE0, IT1 and the IT0, that will be either cleared or set according to the need. So this is the example for the H trigger interrupt. You can go through these things. So all points are very, very important for you. How you can program the...
Sir,
Yes.
sir, you were teaching us the 8051 microcontroller. So, from exam point of view, is not the AVR microcontroller important? That means I want to say that the details of 8051 microcontroller or AVR microcontroller which we should
At the
study.
last, there is a 2 class. At the last, there is a 2 class which are dedicated for AVR microcontroller.
Okay, sir.
So after discussion, discussion of all the resources, internal resources of the 8051, then you will understand the internal architecture of the AVR microcontroller. Otherwise, the assembly statements of the instructions are same.
Okay, sir.
But there is a powerful hardware resources of the features of the AVR microcontroller. Because the AVR microcontroller, I will discuss again. The AVR microcontroller is that means can be categorized into 3 types. That means mega, mini, and with the highest feature. So AVR at mega 8, at mega 16, or at mega 32, these are the examples of the category of the AVR microcontroller, which has a large number of the pin. So that's why I will discuss and I will try to cover within 2 classes at the last. So after understanding all the resources, that is timer, interrupt, and the serial data interface, all these things are available in case of a AVR or Atmega microcontroller. So that's why some classes are required.
Okay, sir.
In exam, in chemistry exam, the AVR microcontrollers are included. But if you do not know better understand the hardware or architecture, internal architecture of the MCS 15 microcontroller, it will be very difficult. Because Atmega or AVR microcontroller is manufactured by the Atmel also. So Atmel Incorporation is producing the MCS 15 microcontroller, 8-bit microcontroller, but ultimately Atmel Corporation Incorporation can produce the AVR type microcontroller. So AVR is a separate technology. Okay. But the instruction of the assembly statements are common to AVR microcontroller. There is no different instruction. So these instructions for NCS 51, these are also equally valid for AVR type microcontroller. We'll discuss in detail about this.
ওকে স্যার। স্যার তাহলে এক্সামে মানে এভিআর মাইক্রোকন্ট্রোলারটাই শুধু ইনক্লুডেড 85 টা
Yes,
নয়?
yes.
আচ্ছা স্যার।
AVR microcontroller included.
ওকে স্যার।
So this is a separate, that is a notes for interrupt and the programming of 8051 8-bit microcontroller. It is better to go through for exam purpose. The diagram is very much clear cut. But for practicing the interrupt programming, Majidi and Majidi book is preferable. For example, this is a C programming body, micro C programming body. So timer interrupt to blink an LED by using the time delay in mode 1. In C program, I have discussed that means header flight should be included. That means the register 51 header flight. Similarly, AVR.H in case of AVR microcontroller programming in C, we have to write, you have to include the header file AVR.H. Including the register 51.H means all the variables which are related to the hardware resources. The variable name is data type. These are included. For example, P1.0 should be written in the C here. So this is defined in the S-bit type functional name, S-bit LED. So in the programming body, we can refer only the LED, not the P1.0. And these are timer interrupt. So the keyword is void timer or the timer void interrupt one. That means ISR for the interrupt one. It's simple, that means the LED is equal to inversions LED. That means the current state of the logical state of the LED will be inverted, means toggle the LED. Then initial values to be loaded timer. That means timer 0 is operated under mode 1, and when the ISR will be completed before exiting, it will reinitialize the timer count as T80 and the TL0 by the 16-bit number. It will be FC66 hexadecimal number. Why? Because according to the program, how much amount of the time delay for the toggling, that is decided, that is calculated. And this is the body of the main program. So initializations of the main program in the C statements are very simple. The same variable name can be invoked, but the same variable name is data type are written within the header file, reg51.8. If you do not use this include statement, there will be an error during compilation. And this is an infinite loop. So this is a never-ending program. Infinite looping is going on. But infinite looping is going on, that means when the timer overflow or rolls over will occur, automatically the ISR will be invoked. So by this way, the toggling will occur over the particular port. What is the port? P1.0, where the LED is connected. But the mainline program is never ending under the infinite loop statement, while within C statement a number, that is void type, no condition, do nothing. So a simple C-like program, but in writing the assembly program, it will be bigger. And programming the external interrupt is like that. It is a structure. And programming the serial interrupt will be, that means will be discussed whenever we'll discuss the serial data communications. Now, what is that? So the basic of the serial data communication is like that. Between the two computers or computing machines, the data byte can be serially transmitted one after another beats in the information packet, that is byte, serially. Now the serial data communication are of two types. One is called the asynchronous communication, another is called the synchronous communication. Again, the communication in general between the two devices can follow three different modes of transmission: simplex, half duplex, and the full duplex. In fact, a better diagram should be there. This is the basics of the serial data communication. Like sender and the receiver, the data will be transferred bitwise, but in case of a parallel, multiple signal lines are required from sending end to receiving end. So there are three types of modes of operation for serial data communication. One is called the simplex, that means the transmitter and the receiver, transmitter will send the data to the receiver, but the receiver, that means in this cannot be directions, cannot be reversed. In the half duplex, this is possible, but not at a time. The transmitter can send the data to the receiver, but in other way, at other time, the transmitter from the that is here will transmit the data to receive in the here. So both the unit consist of a transmitter and the receiver, but they cannot send or receive simultaneously. This is called the half duplex mode of operations. Last one is called the full duplex mode of operation. That means it is fully smart. Transmitter and the receiver will receive and transmit in a bidirectional order simultaneously. So these are the three modes of operation. But how the data will be transferred. There are two types of the communication, asynchronous and the synchronous communication. The data asynchronous communication using the serial data communication is like that. The data coming at the receiving end of the data line in a serial data transfers in all zeros and all ones. That means either digital bit 1 and 0, that is the digital bit stream, will proceed serially. So each digital bit will stay for a definite time that depend on the speed of the data transmission. The unit is called the baud. Baud means bits per second. So that means equal time width will be allowed between the 1-0 pulse. So that by sending, normally these hardware lines will be at the high impedance state or will be at the high logic states. That means it is idle, and this is called the mark bit. Then a logic low, that is a start bit, will occur for the fixed duration depending on the time allotted by the board. Then the actual bit stream will send. So either 8-bit or 7-bit will be sent, and at the last again the high logic bit called the stop bit will stay, and it will be received by the receiver of the same duration. That means all the bit timing are same. So one frame consists of the header byte and the trailing byte. So that is the basics of the asynchronous data communication. The significance of the start bit and the stop bit serves as a handshake purpose. That is software handshake purpose. That means to acknowledge the sender that means yes, the data bytes has been received successfully. If the receiver does not send the start bit, then it will reject the bit. Again, the sender has to reinitiate the process by sending the low byte as a start bit of the fixed duration. Then 8 pulses having either low or high respectively according to the byte information will be sent, and at the last a high stop bit will be transferred. So what is the total number of bits under asynchronous communication using serial data transfer? 1, 2 and the 8. So 10 bit is required. 10 bit is required. Sometimes 2 stop bit may be required to increase the reliability. So 10 to 11 bits are required for asynchronous data communication. This type of data communication is standard called set reset, RS, or send reset, that is receive and send, receive and send 232 standards. So there are different standards of the serial data communication as named as RS-232 standards, RS-232A, RS-422 according to the EIA, Electronics Industries Association, EIA, which has been formed internationally. So according to the RS-232 standards are only for the asynchronous serial data communication. And there is a particular interfacing pins to with the data. Otherwise, it is a 3 lines only required, like this. Sending device is called, that means between the two data terminal equipment, the 3 lines are involved. One is called the ground, common ground. So TXD, that is a transmission line, is connected to the RXD lines of the other device and vice versa. So by this way, the data communication for sending and the receiving the information will proceed. So these are basics of the serial data communication. But in case of a 8051, this can be initiated That means the serial communication interface has internally the three registers. One is called the SCON registers, the control registers of the serial data communication in 8051. Another is called the T mode registers. The registers is used for the serial data communication as well as the timer control actions. And there is a PCON register. Another registers is required. And the data registers associated with the serial data communication is called the SBUF, serial buffer. So ultimately, how to program the serial data communication following the RS-232 standards, that have to be understood. According to the RS-232 standards, the high logic is represented by the negative voltage, -3 to -25 electrical voltage. And the low logic, 0 bit, is represented by the positive voltage, that is +3 to +25. So that is inversion logic. Generally, for TTL logic family, the high byte is represented by the -12 volt and the low byte is represented by the +12 volt. Now, for a serial communication program, these are the baud, standard baud rate. This is not arbitrary. So, speed of data communication will follow these bauds, that is bits per second. 110 baud, 150 baud, 300 baud, 600 baud, 1200 baud, 2400 baud, 4800 baud, maximum 19.2 kilowatt. that is 19,002 kilowatt. That means the speed of transmission cannot exceed this baud. But if we follow the synchronous data communication, then the baud rate may be megabyte per seconds. So that's why the synchronous data communication is much more efficient than the asynchronous data communication. But if we follow the asynchronous data communication using RS232C standard, we have to follow this fixed baud. So how to set this baud? Considering the basic crystal frequency, that is 11.051 megahertz. The machine cycles frequency for 8051 is internally 921.6 kilohertz. Now, that is, in case of according to the diagram, crystal frequency will produce the base frequency, that is of this megahertz. This is divided by the machine cycle frequency of this, and this is divided by the URT controller or the timer by 32, so that we get the frequency of the divided clock of this value hertz. So how this is generated? By the baud rate generator. If you use the timer data byte high byte of this value, these are the value, standard value, so that this baud rate will be generated. So timer clock supplies the serial data communication. In fact, there is a diagram to understand the serial data communication. I will show the diagram, that means how the timer clock frequency is connected or associated with the clock speed of the serial data controller. That is a separate diagram, but this is a functional logical diagram. And SBUF is the 8-bit register used solely for the serial communication. For a byte of data to be transferred via the TXD line, it must be placed in the SBUF registers. The moment a byte is written to the SBUF, it is framed with a start and the stop bits and transferred serially via the TXD line. So this is the function. SBUF also holds a byte of data when it is received from the RxD line. When the bits are received serially via the RxD line, the 8051 deframes it by eliminating the stop and the start bit automatically, because these are not the actual information, it is used for the handshake purpose, acknowledgement. So the 8 bytes will be received and it will be stored to the SBUF registers. So this is the programming body or transmission. SBUF should be sent by the ASCII character D with a single code. Copy the accumulator of the accumulator either from A to SBUF, the copy SBUF into accumulator. So what is the meaning? Copy the accumulator into SBUF. That means accumulator content for sending in should be placed to the SBUF. And this is for receiving. After receiving, it should be placed in the accumulator. So these are the sample statement. Now there is an SCON, that is a very serial data interface controller, very important register. The relative bits are described here. For example, transmit interflag, and this is the receive interflag. What is the purpose of transmit interflag? Set by the hardware at the beginning of the stop bit mode 1 and cleared by the software. So this can be cleared, but it cannot be set by the hardware. That is set bit instruction. It is set by the hardware. How? That will be noticed in the program. Receive interflag means set by hardware at the beginning of the stop bit mode 1 and cleared by the software. Same. So this TI and the I bit will be set, but it should be cleared by the user program. REN, which is SCON.4, set cleared software to enable disable reception. That means if we set 1 REN bits, means the serial data controller is ready to receive the data. And SM0, SM1, SM2, the 3 bits are the mode bits of the serial data communication. What are the modes? That should be described. So SM0, SM1, they determine the framing of the data, specifying the number of bits per character and the start and the stop bit. For example, mode 0, mode 1. Mode 0 means only 8 bits. Mode 1 means 8-bit data, 1 stop bit, 1 start bit. Mode 2 means 2 stop bit, and there is also mode 3. SM2 bit enables the multiprocessing capability. This is not used in general. So these are the definitions of the SCON bits. REN receive enable, TI transmit interrupt. That means after sending or receiving by the serial data controller, interrupt will be invoked to the respective vector address, which I have described just now. When 8051 finishes the transfer of the 8-bit data character, automatically an interrupt will be invoked. Why? Because it raises the TI flag to indicate that it is ready to transfer another byte. Similarly, when 8051 receives the data serially via RxD, it gets rid of the start and the stop bit and places the byte in the SBUF register. It raises the RI flag bit to indicate that the byte has been received and should be picked up before it is lost. So RI is raised halfway between the stop bit and an interrupt will be initiated. But you have noticed probably the vector address for this interrupt and this interrupt are same. Then why the ISR routine will discriminate whether the byte has been received or the byte has been transmitted? That's why it will check independently the serial controller relative bit as TI and RI. Then automatically by logical checking, it is possible that means the byte has been received and the byte has been transmitted. It will be clear during the programming. Programming the 8051 to transfer the character byte serially. These are the steps. T mode register is loaded with the value 20, indicating the use of the timer 1 in mode 2, auto reload mode, 8-bit, to set the baud rate. What will be the baud rate? That will be decided by the TH1. The TH1 is loaded with one of the values to set the baud rate table already shown to serial data transfer. The SCON register is loaded with the value 50, indicating the serial mode 1, where an 8-bit data is framed with a start and the stop bit. TR1 is set to 1 to start timer 1. This is timer run control bit for the timer 1. TI is cleared by CLR TI instruction. The character byte to be transferred serially is written to the SBUF register. Here at this point, the TI flag bits is monitored with the use of the instruction jnbti.xx level to see if the character has been transferred completely. So that means without interrupt, we can monitor, the programmer can monitor the TI bit. Then when the TI becomes 1, means the serial data interface controller is ready to transmit the bits. So again, go to the step 5. That means TI should be cleared. So this is the typical programming body. For serial data transfer, the letter A ASCII character. Then the stage for 8051 goes through in transmitting a character via TXD line. Then for receiving part, the same thing is done. That means the RI bit in the SCON register should be monitored so that the 8-bit is received successfully. When the RI is raised, SBUF has as a byte, if the content is moved to the accumulator or safe place. To receive the next character, go to the step 5. That means RI should be again clear, and this will be for multiple receiving. This will be repeatedly executed. So these are the steps, and these are the program assembly program body for serial data receiving. Okay, but if we use the serial interrupt feature, then monitoring this part can be omitted. That is the monitoring of the TI flag. How this could be done? We have to use the IE registers. We have to set the IE registers. In IE register, we have RI and TI bit set. That means it will enable the interrupt vector. So by this way, we can eliminate this step that is monitoring of the TI flag or monitoring of the RI flag. So these are the algorithm and the steps of the serial data communication following RS-232 standards. Some examples are there. The purpose of the PCON register, which is an additional register, is an 8-bit register. When 8051 is powered up by applying the reset signal, S mode is 0. We can set it to high by software and thereby double the baud rate. That is different feature, advanced feature. So the steps are very clear for serial data communication. You have to understand the serial data communication basic, what I have told. The protocol, set of protocols, asynchronous data communication protocol, not synchronous. And the name of the controller, serial data controller, either UART, Universal Asynchronous Receiver Transmitter, or it may be USART, Universal Synchronous Asynchronous Receiver Transmitter. That means there are some microcontroller which includes the serial data communication controller which can perform the data communication either asynchronously or synchronously. The speed of data communication is much faster in synchronous communication. Why? Because for each data byte there is a additional bits. That is 1 or 2 stop bits and 1 start bit. So either 2 or 3 additional bits are required for each byte communication, which makes the data communication slower. So if the data bytes are n, then how many extra bits are required and the extra time is required? That is maximum 3 into n. So n bit plus 3 into n bit is a total number of bits. As the number of, if the n is the number of bytes, then the total number of bits for asynchronous communication will be 8n plus 3 into n. So which makes 11 into n. So if the number of bytes is much high, so the total number of effective bits under serial asynchronous communication will be 11 times n, which makes the data communication slower under asynchronous mode. But in case of a synchronous mode, the protocol is different. That means the data packets, block of data are sent automatically. Only the header byte and the trailer byte will be there. So it is synchronized. So there is no interleaving bytes, that is the handshake bits, stop bit and the start bit, in case of a serial data communication.
Sir,
Yes.
we have a class from 7:30.
Okay. So for today, I am leaving and I will be sending the these notes. I will update the notes whether you have got all the notes before. So today I am leaving.